Lately, for the video tutorials on NetTouch Plus, I've been focusing a lot on workflow, because I think sometimes more than building some excellent application or script or utility, many times what we're most interested in learning is just simple workflow. How would I go about setting this up so that it works nicely with this and that? Many times that can be one of the most difficult parts of getting set up with a new application, at least at first, until you kind of have your head wrapped around the process. So in a previous lesson, we focused on Require.js and Backbone and getting those to play nicely together with the build process. In this lesson, we're going to switch over to the server side and focus on combining Composer with autoloading and PHP unit for testing. All right, let's get started. Of course, to follow along, you need to first install Composer. We've covered that several times here on NetTouch, so you can search for that on the site, or it's a very simple process. Go to Getting Started, scroll down. You can either install it locally using this command in the terminal, or, as I prefer, install it globally. Once you have Composer installed, you have access to a huge number of packages created by the community, including things like PHP unit. So if I go to packages.org, we can search for PHP unit, and sure enough, that is available. Now in my case, I happen to already have that installed, but if you don't, you've never used PHP unit before, this may not be the lesson for you, or it's not a crash course in testing, but nonetheless, you can install it through Composer if you wish. For this starter application though, we don't really need any packages. Now within my code editor, as I always do, we're starting with a blank slate, so feel free to work along. Now the first step once you have PHP unit installed is to test it out. So let's see what happens if we try to run PHP unit on an empty project. Here I am in the terminal, and I'll run PHP unit. And notice it's going to give me a list of all the various commands that I can use. Now, because we haven't specified a specific file or folder, PHP unit doesn't really know what to do. It can't find anything, so it just spits out the help information. Let's create a test directory. Now within here, as I noted, this really isn't a lesson on TDD. It's just workflow to figure out how can we take advantage of autoloading and Composer and class maps and things like that. However, if you would like a crash course on test-driven development, you can check out the test-driven PHP session that we have here on NetTouch. Just click on the Sessions tab. Now, to make sure that everything is working as expected, let's just use the obligatory calculator class, and we're going to call it calculator test.php, which is a good practice. So let's see how we might do this. We'll say class calculator test, and it's going to extend PHP unit framework test case. So let's begin with a very simple bit of behavior. We will say it should add numbers. So test, add numbers. So if we are testing a class, we're doing unit testing here. I'm going to assume maybe we have some class called calculator. We'll save that to a variable called calc. And then what we want to do is I want to make sure that when we run calc add 2 and 2, what is returned from that method should equal 4. Now this is very basic stuff, so we should all be on board here. Now let's try to do it again. I run PHP unit, and now it's still spitting out the help. Well, what if we try to do PHP unit on the test folder? Okay, well that's bringing back something. If I scroll to the top, it says class calculator cannot be found. And if you think about it, of course that's the case. We're trying to create a new instance of calculator, but we have not created that. So let's see how we might go about doing that. Within the project folder again, I will create one for my app. And within here, maybe, I don't know, this could be a libraries directory, just simple library classes. And within here, we'll create calculator.php, class calculator. Of course, if I run that again, you're going to get the exact same thing because we've created this calculator class, but we haven't referenced it. There's nothing signaling that we need to auto-load the class, so still it can't find it. So your first thought might be, well, let's just require it. Okay, well, let's try that as a first step. We're going to be using this from the root of our project, so we can require app libraries calculator.php. That will work. If I run it again and I scroll to the top, now you can see, yes, it did find the calculator class, but now it's letting you know, hey, I couldn't find any add method at all. That's your next step. But this is a bit of a dated practice because if you think about it, we would have to pull in all of our classes and dependencies for every single test file. So as you can imagine, that quickly becomes somewhat cumbersome. Why don't we instead take advantage of auto-loading using Composer. So once you have Composer installed, if I were to run it, you'll see, yep, we get documentation as well. But as I noted earlier, in our case, we're not leveraging any packages. However, if you're doing some testing, you absolutely would. I would recommend checking out the Mockery package, which provides mocks in PHP Unit, but a much more readable and elegant way than how PHP Unit offers mocks out of the box. Nonetheless, we're not going to focus on that. We're just going to use Composer's built-in auto-loading capabilities. So let's create a new file called composer.json. And this is where we can specify what to autoload. Are we doing PSRO autoloading? Are we using just a simple class map? What about the packages that we require? Now we can specify that we want to autoload using this autoload property. Now within here you have a couple options. We can specify we want to follow PSR0, which is a popular convention. You can refer to a recent article on NetTuts where we cover all of that. It's called PSR. However, I think the easiest introduction, at least at first, is for us to only specify a class map. And then if you want, we can take a look at using PSR autoloading in a future lesson. So let's change this out, and instead, as I noted, we're going to specify a class map. Now, which directories would we need to autoload? Well, in this case, all we are working with is app libraries. And that's it. So now if I switch back and I run composer install, if I switch back, notice that we now have this new vendor directory, and it contains the autoload.php. And also, if I open up the directory, you'll see that it creates a class map. So notice that it's simply an array of key values. So we have calculator, and that points specifically to where that file is stored. Or if we were using namespacing, as we will shortly, then that would be updated. Now, one thing I want to show you though before we move ahead, what if we had something as well like app/models? We would need to run a special command to update this file. We need to dump the class map again. So we would do composer dump autoload. Now in this case, because we don't have a models directory, it can't find anything. So let's just do this temporarily because I do think it's important to show you how it would work. Within models, maybe user. This will all be deleted, by the way. All right, let's run it one more time. But now if I go back to our class map, notice that it has updated. So keep that in mind. Anytime you add a new directory to your autoload area, then you also need to run composer dump autoload. In this case, though, I can delete all of that, go back to composer.json, get rid of that, dump it one more time so that we get a current version of our class map. So if I close these now, let's see what has this offered us. Well, if we go back to calculator, let's see, will this just work out of the box now? Does autoloading mean that we can just run new calculator and it will immediately know what we're doing? Well, let's try it. We get rid of the manual require, and now if I run PHP unit test, go to the top, you'll see, no, it still can't find that calculator. If Composer provides this autoloading capability built in, why are we still having to manually include it? Well, that's not actually the case. We just need to include the autoload file, which you could even do in a bootstrap. But for now, let's place it within here, and then we'll fix that shortly. I will require vendor autoload.php, and now if I run it again, you'll see, yes, now it is working. So you might be thinking to yourself, well, what did we save? Before we were requiring the calculator class, now you're just requiring the autoload file. Well, we're actually achieving a lot. First, this require block, as I noted, does not need to be placed within the test file. You just need to have some kind of bootstrap file where you bring that in. And second, even if you did keep it in here, it would still make for an easier setup. So let's get this test to pass. I'm going to switch over to our calculator, and we'll just create a quick function add. You've seen this 1,000 times. We will return x plus y. All right, so let's run it. And sure enough, we are now at green. So that's really easy. So before we move on, the next step is I want to get this autoload require out of this class, because for every new class, at least at this point, I would still have to require vendor/autoload, or I would have to create a custom class that extends PHP unit framework, require that, and then all of my tests could extend my custom test case. But in this case, we're going to do something a little different. We will instead create a PHP unit.xml file. So this is essentially the configuration for running our PHP unit tests. And that way, when we run PHP unit, behind the scenes, this file will be read and it will follow all of our settings rather than us having to manually do it each time. Now I happen to have a short little snippet that I will paste in. So notice this is simple XML. We are creating PHP unit and we are specifying what the bootstrap should be. So that just means before your tests are run, do you have some kind of bootstrap file that will do some setup? Well, in this case, yes, we want to make sure that we load vendor/autoload. Next, we just have some basic settings. You can get rid of a lot of these if you want to keep it simple. These are just simple configuration options that I tend to prefer. Next, you can have more than one test suite, and that way, when you're running all of your tests, if you really want to focus on one area of your application, you can store that within its own test suite. In our case, though, I just have app tests. We're only going to do one, and the directory will be test. If I go back to calculator test, I can get rid of this require statement because I know before this test runs, we're going to first load the autoload.php file. Now let's try it. I will run PHP unit alone. I don't have to specify test anymore. I run that command and we're getting the same thing. Excellent. Now the next thing that I want to do, I can close this out, both of these, is I want to implement namespacing. If I'm autoloading these files, it's very possible that maybe there will be some other class in my project that I don't even know about that has the same class name. And that's why I want to take advantage of namespacing. So within my calculator class here, we will give it a namespace of app libraries. Notice that we are following the directory structure here, app, libraries, and then the name of the class. And that way, from outside of it, if we want to create a new instance of this class, you would do new app, libraries, calculator. So now that we've added our namespacing here, something is going to break. Let's try to run PHP unit again. Or you could always do something like alias p equals PHP unit, or you could take advantage of auto testing. But now notice that we run it and we're back to that same error. The class calculator could not be found. And that's because, think about it, we go back to our class map. Well, this is no longer correct because we've added namespacing. So let's revise this. Composer dump autoload. And if I come back, notice that it has now updated to reference our namespace. But still, if I run our tests again, we're still going to get that error, class calculator not found. Well, think about it. If we go to calculator test, we're just trying to reference it like it's a global class. But now we know that we've namespaced it. And if you're confused with namespacing, at least an easy way to get started is just think about the way that you would organize files in Finder, in your folder structure. If you have let's say two songs that have the same name, well, if you stored those in the exact same folder, as we all know, that would not be allowed. You can't have two files or MP3s that have the same name, so you would have to use a different name. However, if you were to move those into their own folder, maybe according to the artist or the band, then you could have two files that have that same name. But then, of course, if you do want to listen to song number one, well, now that you've moved it into a new directory, you need to reference it accordingly. So let's go back to our tests and do that. This time we will do app, libraries, calculator. Run it again, and now we're back to passing. However, I'm happy to admit that this can be a little cumbersome. Some may feel that that is not as readable. So let's do this at the top then. We're going to say I want to use app, libraries, calculator. I want to make sure I use that class. And now that I specify that at the top, I can remove this altogether and bring it back to new calculator. Again, if you want to go back to your folder structure thinking, just imagine that as you're going to open app, libraries, calculator, and then within there you can open up any file or MP3 that you want. And the same is true for namespaces. Let's run it again to make sure that nothing broke. Great, it's still working. So already we're taking advantage of a lot. We're using PHP unit properly to unit test our classes. We're using Composer to bring in any additional packages that we might need, like Mockery. We're using Composer's built-in auto-loading capabilities. We're making use of namespaces. We're following a lot of tried and true best practices. To finish up this lesson, let's just consider a couple different options when calling an add method and where things might go wrong. We know that when we call add 2 and 2, that 4 will be returned. But what would happen if we pass, for example, an array and null? Well, shouldn't that be factored into the equation? Should an exception be thrown if the arguments that are passed are non-numeric? Probably so. So let's write a test to make that happen. We'll say test throws exception if non-numeric is passed. Now, something to notice here is that when I create my function name, if you're thinking, wow, that's a really long name, that's a bad practice. Actually, no, it's not. When you're writing your tests, you want to make them as descriptive as possible. And one of the bonuses to that is when others are viewing your tests, it's almost like built-in documentation for them. They know, hey, when I'm using my calculator, I have the ability to add numbers, but it looks like if I pass arguments that are not numbers, an exception is going to be thrown. It's free documentation for developers, which is really nice. So let's see how we might do this. Well, once again, we're going to create a new instance of calculator. Looks like we're repeating ourselves a little bit. Let's keep that in mind when we start refactoring. But nonetheless, we will call calculator add a, and then maybe an array as the second argument. We know that that should not work. But let's try to run this PHP unit, and let's see what we get. Unsupported operand types. So this means we tried to add the arguments together. If we come back, we're trying to add a string and an array, and basically PHP is getting pissed off and saying, hey, stop trying to make me do things that I can't do well. So we should check for this. We shouldn't blindly assume that X and Y will be numeric. So let's take a first stab. Now, this will not be the correct choice, but I want to show you both steps of the way so we can see how to refactor and apply additional tests. We will start by saying, well, what about if X or Y are not integers? Well, let's say if not is int X or not is int Y. If that happens to be the case, if either one of them is not an integer, so we think right now, that means that we should throw an exception. Throw new invalid argument exception. So we think that will work. Let's see why that won't work though. I'm going to run our test again, and now we're going to get this issue class app library's invalid argument exception not found. So that means that it thinks that this is our custom class that is stored within the app library's namespace. But how do we just say, no, we're just talking about a global class that's built into PHP? Well, in those cases, make sure you preceded with a backslash. Now we run it one more time, and we see it tried to run this test, but then an invalid argument exception was thrown. So we do know that this is happening. However, we also know that what we're intending here is to ensure that an exception is thrown. So we haven't yet written a test to say we expect an exception to be thrown. Well, we can do that in PHP unit, actually a bit interestingly, by placing it almost like a doc block. Here I'm going to say at expected exception, and what is the name of the exception that I expect to be thrown? Invalid argument exception. Now let's run it. And sure enough, we're getting 2 tests passed. Now, I want you to be careful. It has to follow this syntax. So if you happen to be using a simple comment, something like that, well, no, that's not going to work. You're going to get this weird issue. Make sure that you are following this pattern right here. But essentially, this just says when this method is called, we're going to expect an exception to be passed. And then within here, we write the necessary code that we think should trigger that exception. Now, we think this is good, but why don't we consider another option? So far, we've only ensured that when you add 2 plus 2, 4 is returned, and when you add non-integers, an exception will be thrown. Let's try one more up here, and let's say this time we're going to expect 5, but this time I'm going to use 2.5 and 2.5. So I'm going to expect 5 to be returned. Let's see if that works. Run it again. Oh, now we're getting an invalid argument exception again. So what that means is, at some point, this line of code ran. Now, if you know your math, you know that, well, is integer probably isn't the right choice. We want to just make sure that it's numeric. So instead, we'll use the isNumeric function. Now, if I run it one more time, yeah, now we're back to passing. So this shows that sometimes it's beneficial to consider a variety of different things, just in case you worry or fear that they may fail. So maybe you just want to double check that when you add maybe -3 and 1, well, in that case, even when we're dealing with negative numbers, that should be equal to -2. Let's run it, and good, that's still passing. But this starts to get a little bit muddy. I'll show you 2 different ways that we could solve this. The first choice might be to store a values array. So we could do something like create an array, and within here we just want to have the x, the y, and what we expect the sum to be. The next one will be 2.5, 2.5, and that should be 5. And then the third one is -3, 1, and that should be equal to -2. Then we could do a for each statement, and we could say for each values as, and maybe numbers. That's a bad name, but that's okay. And then we just run our assert equals again. So I'm going to assert that the total is that second index here, and our test is going to be, just as below, calc add numbers 0 and numbers 1. Now I can remove all of this, so we've dried up our code a bit, and if we run the tests again, it's still passing. Great. Now the advantage to this is anytime you want to try something else out, maybe you want to, and again, this is a very elementary example, but you can imagine for more in-depth issues. Maybe -9 and -9, well, that should be equal to -18. We run it, and now it's running 5 assertions rather than 4. So yes, this is certainly a way that you could go about it, but we can even do a little bit better using PHP unit. Let's abstract this out, and we're going to create a new function, and we're going to call this input numbers, and paste the values in. Now in this case, rather than storing it in a variable, I'm going to return that. Now, when we call test add numbers, I can get rid of this for each, because that's going to be done automatically by PHP unit. And we can specify as much by using the data provider option, and we called it input numbers. So now this function is going to be called for each item within this array, and it's going to accept x, y, and the sum for this one, and this one respectively. If you were to add another one, well then a fourth param would be sent through as well. Now the only thing that I need to change is to update the numbers. So that will be x and y. Let's try to run it again, and good, it's still passing. So this is a much cleaner way to go about it. When you need to run a function through multiple different options, this would be the way to go about it. The final thing would be, we could keep the new instance of the calculator within this function, or if it's going to be shared through all the tests, why don't we instead add that to the setup? And we'll say this calculator equals a new instance of calculator. Then right here, I can remove that entirely and further clean this up, like so. And the same for the second option. So now we've refactored our tests, which is good as well. You refactor your production, but also there are times when you need to refactor your tests. But we run it again, but now we can see, oh, there was an error. And if we didn't have these tests, we may not have even realized that we had done something wrong. So already we are realizing the benefit to this. And so what we see here is call to undefined method assert equals. And that's just a mistake on my part. This assert equals, and we update it here. So we fix our error, we run it again, and now all of the tests are passing. And that will do it for this lesson. This project is up on GitHub, so have a look through it, see if you can extend it, see if you can try out some different classes. Maybe you need to test out some kind of geolocation service, where you want to test the latitude and longitude, and maybe that will be sent to Google Maps. There's lots of different options. The most important thing, though, is that you just dig in and you experiment with it. And that's the only way you're really going to learn all of this workflow. My name is Jeffrey Wei, and we'll see you later.